Let me walk through what are the different ML and AI models we use across these steps. We use unsupervised clustering to group together millions of alerts coming from several sources into symptoms. And these symptoms can be used to correlate alerts into symptom groups, and that entails in noise reduction. We also use unsupervised clustering to group together the log messages and see how this grouped or clustered log messages trend over time, and if there are any correlation to point us to any root cause of issues. We also use regression analysis to forecast alert volume for specific symptoms, specific alert conditions, or for specific applications, and trend how those alerts would appear over time. We also use regression to detect seasonality for alert volumes, log volumes, and also detect any anomalies that could impact your system. We collect a lot of metrics for incident triaging, and we use correlation of different time series metrics to see if any of those metrics are correlated and if they're impacting your system, and in turn go and infer the root cause from these correlated metrics. We also use classification to identify incidents that are similar so that this incident can be solved in a similar fashion and similar way. So as I talked about the three different models that we use clustering, unsupervised clustering to group together alerts and logs to find out symptoms or trends of different log symptoms. We use regression to detect seasonality, detect anomaly, and forecast how a certain log would be, how certain logs would be trending, and what will be the forecast for a certain alert based on symptoms or based on certain conditions. We use classification to identify similar incidents, and the similar incidents can be solved in a similar fashion. So we would give recommendations or suggestions to users. We have seen similar incidents solved by increasing the DB partition, and so the next incident that comes as a similar symptom can be solved by increasing the DB partition. And we use classification to predict incoming alerts into different symptom clusters. So now let me walk through where we use this in our tool. So we provide user to run multiple experiments, and then they can use these experiments to fine tune different parameters. And once they find that this experiment works best, they can use and activate it to create different clusters or symptoms or different regression charts. So let me walk you through how do I create a unsupervised clustering model. And here I'll walk you through, this is alert cluster. And I would select alerts from, let's say, from beginning of the year till now. So 1st of January till today. Use clustering pipeline. And here we provide a variety of filtering mechanisms to see what kind of alerts you want to choose based on different applications, based on stack, based on severity. And for our example, I'll select all alerts. And then we go through multiple steps. We go through the vectorization. And for that, we have multiple algorithms that can be used. And we recommend word2vec, and what we tried out that gives you the most optimal vectorizations. And the size of 30, the dimensionality of 30. And I'll use skipgram as my training algorithm with a window size of 3 words on both sides of the target word. And for the clustering options, we can use HDB scan, DB scan, and K-means. And HDB scan seems to give us a good result. I'll also choose a minimum cluster size of 50, and if the alert volume is really large, we can increase this minimum size to up to 1,000, and then the minimum sample as 1. So based on the minimum cluster size, I can also select a minimum sample size. And do I want prediction data which can be used for classifying incoming alerts? And do I allow single clusters? So user can use this experiments and tweak at different parameters and finally arrive at clusters that really match their need. So once they run this experiment, it goes and gets all the alerts from the system, starting from the first of the year until till date, and tries to create different clusters for those. So let me go back and take a look at that what we have created. So if you look at, we run many experiments, both a regression as well as clustering, and I see there's one clustering experiment is active, and it created 34 clusters. So let me go and see what are the different 34 clusters are. And if you look at it, these are the 34 symptom clusters that are created by my experiment. And this is the different symptoms that exist in this particular system. Interface is down, service SQL agent is not available, CPU utilizations exceeded the threshold value, device is unreachable by SNMP, device unreachable by ICMP, NTB is not configured. And we use out on proprietary devariables, and devariables doesn't mean that you can do it at every level. It has to be very smart. And then we group together into different symptoms. Once the symptoms are created and it is activated, the symptoms will be available for creating your correlation groups. So I saw the 34 symptoms, and I would go and now create one policy, and that policy will be able to create multiple groups based on this. So I'll create a correlate groups by symptoms, section symptom groups, and I will do it for all minimum severity for this alerts groups would be let's say critical, and the expiry time in given cells in 13 minutes, auto clear after last update in minutes, that should be 0. And I can filter. I don't need to filter anything now. I can say I want to group by symptom clusters. That's it. So now once I do this, I created one policy, and this policy, as the alerts come in, it'll create multiple groups for each of the symptom clusters that we created in our experiment. So there are 34 symptom clusters. So every time a new alert comes in, we'll try to predict into one of the groups, one of those clusters, symptom clusters, and create a group for that. So as you can see, once I create the symptom clusters and enable it, it'll go and create multiple groups for, and also we show how many groups got created and how many alerts got matched into that group. So this is a quick and easy way for users without having to do a lot of analysis of what are the different alerts, how I can identify different burst alerts, how I identify different alerts for the different applications or different assets. This is a quick way to just one simple experiment run. Once you run the experiments and identify which is a right clusters that for your need, and then once that is done, just create one policy, and that will correlate alerts and into multiple groups. So this is one way that we use ML unsupervised clustering to predict alerts into groups. The next, I would like to show you how we use regression. For regression, we run multiple experiments again, just like we had um, gone through here, multiple machine learning experiments. We had clustering and regression. And just like for um, clustering, I again go through this pipeline, call it regression. I want to see how the critical alerts that are coming to my system over the last, let's say, 3 months, starting from May 1st to almost 4 months, and how's my trend for this regression, was there any anomalies, and was there any kind of trend that will happen. So again, I'll see and only do severity based on critical alerts only, and then I'll go through the different algorithms to do either Facebook profit or different parameters that I can choose here to create it. Once I run this regression, it takes about 20 to 30 minutes. Those regression models will show up in my project. We have run multiple of those regression models. Let me go into that. And here, as you can see, we have created regression models for a particular symptom, which is interface packet discarded exceeded a configured value. We have done it for alerts for the last 1 year. We done for the alerts for CPU utilizations exceeded a certain threshold value, the configured threshold value. As you can see, this gives me the trend of my alerts for that particular symptom or particular severity or particular application over the time. And I've also used to predict how the trend would be. So I ran this regression on August 17th, and it gives the next 7 days prediction how the trend for this particular alert would be. And this information can be used by operators to do some proactive work in terms with certain alerts are becoming trending high. They can take the remedial action to address those and not impact the services in your system or in a network. So these are the two uses of clustering and anomaly detection and regression and forecast. I'll also show another example of where we use correlation for. So as we group this alerts into groups, and we create a for each group we create an incident. And once an incident is created, most other competitors, they would just get some information about it and do it. What we do is we go and collect variety of metrics for different assets that are affected by different alerts. We go to those assets and collect a lot of data. As you can see, we discovered it has this many. There's a web layer and a app connectivity layer, storage, network layer. We detect just based on the IP address. We go and find out the different connectivity, and we detect all these different layers. And from these layers, we collect a lot of metrics. So for example, for the website, we collect the app latency. How is my application latency over time? We collect the number of calls from app dynamics. We go and collect the different database metrics, from memory usage to the different database bytes transferred, CPU usage, and also different commands that were executed by the different database services. And once we get this time series database, time series metrics, we correlate this metrics and see if there's a similar patterns for different metrics. So we group them into different correlation groups. And then these correlation groups can be used to infer if there is a particular trend that is causing this incident. So that is the other place where you use correlation to identify or infer the root cause. So these are the areas that we use. We use unsupervised clustering. We use a regression model for anomaly detection, prediction of data, and we use classification to infer the root cause of different incidents. That is, these are all different places we use ML for in our AI solutions, and we would be happy to provide more details if you're interested. Thank you.